Good morning. How are you? Thank you for the warm introduction, and especially my thanks to the organizers of GeeCON for the kind invitation to speak to you all this morning. As was noted, my name is David Moore. I'm a technology leader with a company called Sabre. It sounds like many of you may know the company. For those of you who don't, we are a technology organization, and we provide software products and operate software products for the global travel industry. Sabre has a long history, many decades, and as a result, we have, as you might anticipate, a lot of what are referred to typically as legacy systems. We have a wide variety of technical stacks, a wide variety of languages in use, a wide variety of solutions, some 300 some odd products. And so as you might anticipate as well, that introduces a lot of complexity to the work that we do, right? What I'm going to focus on today is what I've called wrestling the monolith. If you know monolith, it's often a word that's used to describe a large legacy system. I'm going to ask you to step back. There's a lot of great content to the conference this year and a lot of very deep technical topics. But I'm going to ask you, at least for the purpose of this keynote, to step back and to consider the social and organizational aspects of how you approach large systems, and particularly re-architecting, refactoring, re-platforming large systems. As I note in my subtitle up in the top left-hand corner, from my perspective, organization leads the way. It is the single most important determinant of your success when you're leading large efforts around building, refactoring, re-architecting, re-platforming, or as you'll often hear it referred to, modernizing an existing system. So let's get started. Stating the obvious, the painfully obvious for everybody in the room, change is constant, right? I think we have enough experienced folks here at various levels of leadership and development and architecture and engineering and testing, et cetera, to know that the way that systems actually work in real life is you start with an initial launch of a product or a system or a platform, and over the years you accrete code, layer by layer, right? Release by release. You add features and functionality, new capabilities. The implicit and explicit dependencies multiply. The code gets more and more complex, and ultimately you wind up with what you might refer to as a hairball, right? Just a knotted bundle of string and hair that you have a tough time teasing apart. That is the reality that most of you and all of us, candidly, will deal with throughout your career. It's rare in my experience over some 30 years that you get to build a system from first principles, from greenfield. Almost every system you touch will be a legacy system. I don't care if it's multi-tenant SaaS, it's a web product, it's a legacy system implemented on open or mainframe systems. Doesn't matter. Most of what you touch is going to be the code that some other engineer first crafted. So every one of us will deal with legacy systems. More importantly, what's going to happen is at some point in your career, you're likely to be asked to lead or to participate in an effort to re-architect, refactor, re-platform, to migrate an existing set of code. So we do this all the time, but we have a really bad history. If you look back over the last 3 decades, the trail is littered with the wreckage of attempts to re-platform, to rewrite, to reimagine a system, to refactor a system. The techniques are straightforward, relatively, right? The architectural design patterns, the code patterns, the approaches that you use. I think everybody in the room probably understands facades and proxies and wrappers and all of that. That's all fairly intuitive and obvious. So why then do we fail, right? Why is it such a struggle? I'm going to assert to you that the key determinant in whether or not you're going to be successful in these efforts is really how you organize around those efforts. It's not the technical aspects per se. As I'll say later, technology is easy. People are hard. In my opinion, organization leads the way. So who am I? Just so you know sort of context and why I'm going to say the things that I'm going to say. So I started in the late 80s as a developer. I have slung in anger on real systems, real commercial products, real live systems in about a dozen languages since the late 80s. And C, C++, and Ada in the late 80s and early 90s. Smalltalk, large distributed systems in C++ and Java in the mid-90s. On architectures like, and boy, this will scare some of you how old some of this stuff is, like Corba and DCOM and DCE and RPC, enterprise Java, web services, etc. I've done that in the role of leading architects, leading development teams, UX teams, QA teams, as CTO, as head of business units, building shared services. And I've done it in professional services for clients and within organizations. Organizations from pre-IPO startups with like a couple dozen people to Fortune 50 companies with 100,000 employees. So I've seen these situations from a variety of perspectives. That was the key point. So this isn't a one-time example. This is something after you've lived through a few times and you have the deep scars I do from the mistakes that people make. I'll relate that I recall the launch of a Fortune 50, $200 million program to launch a brand new e-com channel, to move it from a Microsoft stack to an ATG stack, Java stack. 300, 400 people, multiple years. We launched, and in an event that became the core of my good friend and colleague Mike Nygaard's book called Release It, on building resilient architectures, we launched and we were brought to our knees by a single blocking call in a Java library. If you don't think after that I have an aversion for and a particular concern about serialized behavior and brittle integrations and dependencies, then you don't know me too well. I carry those scars, and I'd say that those scars and those lessons are the things that shape us and that teach us as engineers. So let's get started. So the opinions I'm going to share are really just my opinions based on my experience. Some of them may seem counterintuitive, some of them rather obvious. When I'm talking about things like Conways Law and perspectives like that, that's nothing new. I'm not trotting new ground. That's been pointed out by much smarter people than I for the last couple decades. But I'm going to try to add relevance and pragmatism to these and talk about how I perceive their use and their applicability in real life. So the first thing to understand is that change is constant. No kidding, Dave. Like I said, I'll point out the obvious on occasion. So change is constant. Systems accrete code. They accrete layers and layers of features and capabilities. Candidly, most of you live the reality that the organizations that fund the work you do never provide you an opportunity to go back and re-examine the core assumptions you made around the architecture and the design at the outset, right? Making this more difficult is the world changes. The demands on the system change, right? Users evolve, expectations evolve, computational complexity increases, volumes increase. People use the system in different ways. You continue to add code and code and code, and eventually what happens in most organizations is you reach a point of brittleness. That's sort of the first sign, right, that you have an issue. And what will happen is the system will begin to exhibit behaviors that are like these analogies I use, right, like sort of the ball of hair. You go in and you modify some code here and you pull on this little string of hair and something moves over here. And it can get really tough to untangle those, again, those implicit dependencies especially, right? Dependencies that aren't obvious, that are fairly subtle or nuanced. Data dependencies, other dependencies between systems. you can wind up with a situation that my friend Mike Nygaard referred to as quantum-like behavior. I thought it was a pretty funny way to express it, where the subtleties of the dependencies and the code is so complex that it's not even obvious why a change here causes a change over here. So you go in, you modify some code here, and suddenly something breaks over here. It's awesome. When you've got a situation like that, usually what winds up happening is you're going to wind up in a position where, to your managers, to your executive team, to a board of directors, you're going to make a pitch to re-architect a system. In his presentation, Architecture Without an End State, Mike talks about this in a sort of a snarky way, is sort of the Ginsu knife analogy is what he uses, about how you make a pitch. And it points out some common failures of ours to be candid and straightforward about complexity. What usually happens is we paint a picture of a big hairball. Those models that are up there, those are live models, are real models. I think the three on the right towards the bottom, those are from, I think I did those in about 2004, 2005. The one up there at the top left is a dependency graph of a single method. That's from a refactoring of a big multi-tenant e-commerce platform a few years ago. So usually what winds up happening is you walk into a room and you say, hey, look at this big hairball. And then you say, what we're going to do is we're going to give you this. And you throw a picture up of a pretty layered cake. You know, the Lego diagram, right? You've probably all seen dozens of these. I think in the 30 years that I've been around, since the 80s, I've been looking or making these darn diagrams, these beautiful layered cakes. One of the dangers here is that's not an architecture. When you get old and you're not coding anymore, maybe that's about as close as we get to architecture, right? It's a useful way of describing a set of ideas and of organizing a set of domains, but as soon as you push down with any effort into the architecture, it becomes more complicated very quickly. I joke with some of my team that I'm at the point now when I see a group of architects standing up at a whiteboard or presenting something like that and drawing a layered cake, I kind of throw up in my mouth a little bit. I'm sick of seeing layered cakes and Lego diagrams. That's not architecture. They're pretty pictures. I worked for a CTO and a founder of a software company where we were doing very large-scale distributed systems for payers and providers in the healthcare space in the US. It was really wickedly cool stuff. He was an ex-chief scientist from Cray, and he was a linguist and seminary student, and he coded every day, founder of the company, right? And we were doing this really cool stuff with DSLs and code generators and compilers to gen systems, right? Sort of generative solutions. And we used to joke that there was an old comedy show in the U.S. in the 90s and 80s called Seinfeld, and there was a scene where the guy walks up to get a car from a rental counter, and he says, I've got a reservation, and the agent says, well, no, you don't. Well, you do have a reservation, but there's no car. And he says, well, wait a second, that's sort of the whole point of the reservation. And then he stands there and very animatedly says, anybody can take a reservation, it's the car that matters. It's sort of the same way with these Lego diagrams and layered cakes. Anybody can draw a picture. It trivializes the complexity of the system. And what Mike argues in his, and states very well in his talk, Architecture Without an End State, is it's not genuine, it's not correct, it's not appropriate to posit that you can have a single model that represents the complexity in any system of scale. The idea of an enterprise data model or a common object model, I've seen too many organizations run into the shore, run into the rocks with that kind of effort. Life is more complex than that. And I'm going to talk in a little bit about how to manage that complexity from a technical perspective, but also from a social and organizational perspective. So getting started. There's a quote here from Voltaire, and I think it's spot on. I think it's one of the key things to remember, and where I see a bunch of organizations fail, is they pursue absolute metaphysical certitude, a false precision down to the finest detail in budgets and plans and designs, and they spin and spin on this, right? Ambiguity is uncomfortable, but it's real. And you actually will never know how a system will perform or how users will consume a system until you get it live. Embrace the ambiguity. Be comfortable with it. It's a good thing, right? It's a good thing to be humble and admit you don't know everything, right? Because it'll drive you to make better decisions about how you approach building and deploying systems. So what are some key principles? So first, getting started. I have heard this often referred to as define what good likes. I like that. That's a good way of thinking about it. Set your North Star, right? View what you're about to do as working with a compass and not a map. You're not going to be able to define every step along the way and every outcome and every twist and turn, right? So define your architectural goals. Define the key trade-offs that you want to make in terms of key architectural decisions, key economic decisions, key schedule and timeline and resourcing decisions. Set the context, right? And then realize that architecture and execution and development are local activities. Think globally, act locally. Don't attempt to eliminate ambiguity. Again, I think I might have said that before. In case you didn't hear it, don't attempt to eliminate ambiguity. Ambiguity is a reality. Increment and evolve in all things. So if we're talking about a team structure, a process, or a software system, the Agile approach, and I get uncomfortable with labels. When I was first doing like first-gen methodologies, like Rumbaugh and Jakobson and Bucha, Werfs-Brock, Schleiermiller, those folks back in the early 90s, what I quickly came to realize is that there were sort of methodology Nazis, right, that wanted to say that all you needed to do was strictly follow a recipe and everything would be okay. That's nonsense. Some of the methodologies had good aspects, some of them were weaker. I liked Jakobson's narrative use cases. I liked Bucha's OIDs and ways of dealing with dynamic behavior. I liked Rumbaugh et al.'s approach to sort of more static class models and data. And what I liked was to sort of mix and match, right? To step back and synthesize the detail, right, and find out what works organically for you. Okay, that was a little weird. And so the same thing with Agile, right? A phrase a Agile coach on a recent Agile transformation initiative that I did, a woman named Stevie Bourne, used to say, Agile Smagile. I like that. Agile Smagile. I don't care about the titles, the names, the recipes. My God, we're engineers, right? We should be able to think in a more sophisticated manner about this. What's important are the behaviors, right? Small deliverables, iterate, fast feedback, constant communication, and small cohesive teams driving work forward. That's what's important. I don't care if you call it Agile, Smagile, it doesn't matter. Test and experiment. I don't like the idea of fail early and often. I don't want to fail. You're going to fail. You're going to get scars. That's okay. But what I want to do is I want to create a hypothesis. I want to test it. I want to see what happens. I want to learn and iterate. That's why for the last 20 years, A/B testing, multivariate testing is so popular and such a best practice. Is organizations have realized that, at least with respect to users, you can't anticipate the way users are going to consume your system. So don't pretend that you can. I've got a colleague right now at Sabre who's an ex-military guy, and he always says that the battle plan always falls apart on first contact with the enemy, right? Best laid plans of mice and men. What's going to happen is you're going to have absolute certainty that you've got this great idea, you're going to test it, and you're going to find out it didn't quite work the way you planned. So embrace that. Avoid moonshots. Don't bet the whole company on one big idea. Small increments, small bets, technically, organizationally, in all things. And leverage business opportunities to advance your mission. So you set the goal, right? And you set the architectural objectives that you're trying to reach. and then use small commercial opportunities to push that vision forward. I have a deep suspicion of a bunch of smart guys sitting off in an ivory tower and thinking big thoughts, right? I was with a Fortune 50 retailer, and we were launching this big, huge program. And we were sitting in a room with all the people out in open cubes, open seating, 2 stories. And in the middle of this huge facility, there was this tower with a set of rooms up at the top that had glass windows. And there was a catwalk that went across to reach it. And all the architects set up there. I called it the God Pod, right? They set like little gods up in their little glass tower, and they issued architectural edicts down at the team. And at one point I went up and I grabbed the head of this architecture team, and I said, we've got a couple hundred people down here, vendors and interactive firm and some offshore guys, and then all our employees. And we actually need to start building software here pretty soon. Are you going to come down and help us build and deliver this thing? And this guy said something to me that I wanted to just stencil and hang up behind my desk. He said, "We are enterprise architecture. We don't build anything. We don't deliver anything." What? If you have that kind of sense that dynamic is going on, take it out in the backyard and put it down. Stop it. It is through engaging in real software product development that architecture has value. And constraint is good, right? When the patterns movement really took off in the 90s, one of the key things, if you look at Gang of Four or any of the other people that wrote on patterns, is the idea of a pattern is a solution in response to a problem with a set of forces or constraints around it, right? And the elegance in your solution comes from how you respond to those forces, how you balance flexibility and performance, right? And provide a solution. There is no right answer. One last thing, and then I swear I'll get off this slide. I want to watch my time here. The one last thing is I've also watched a lot of these efforts where you go off and a bunch of smart guys sit in a room and they imagine the perfect framework or the perfect platform or the perfect service architecture. I might have participated in one of those, or one or two of those in my career, I'm sorry to say. What usually happens is it's taken up ostensibly to drive reuse, right? To drive efficiency in the architecture, to give developers the ability to go faster. Again, this is one of the dangers we fall into. It's hubris, right? You carve a bunch of smart folks off, they sit in a room, and they try to imagine how this thing is going to be used. And then they keep generalizing and generalizing. Well, what about this use case or this use case? And they add layers, and they add abstractions, right? And they defer decision making. And pretty soon the thing becomes slower and slower and more complex and more difficult to use. And then now think about it in terms of your users, right? The developer. This poor person is going to look at this thing and say, I can't even apprehend this thing, let alone navigate it and find what I want. I've got to build something. It doesn't perform worth a darn. It's hard to use. It's slow. It's cumbersome. I'm just going to go write my own thing. So it winds up perversely incenting the behavior that you claimed you were trying to stop. Get engaged with real life, right? Build real product. Build small things and iterate. That's the way to learn to drive value and to really test your architectural decisions. Quickly, techniques. I'm not going to spend a lot of time on this because, again, I want to talk more. I think this is a deep topic and probably for another speech or another talk. But I do want to at least give a sense of how I found that I like to approach this. So if I'm looking at a big swath of a system, a big code base, and I'm going to refactor it, right? I'm going to make it more well-formed. What I will first counsel you to do is think about domains, right? Just define the big domains, fairly obvious point. A key aspect here is the 80% rule, right? Don't try to achieve absolute perfection in this model. Define the big boundaries, Done. Then use what I call fracking. I don't know if you know fracking, right? It's very big in the US right now. It's this idea that you inject pressure, fluid, down into a geological formation and it causes the rocks to split apart. So think about the code base like that. What we want to do is we want to break it into the big chunks, do that initial boundary setting and decoupling, and then iterate within those domains. Again, common sense. I'm going to argue that arbitrarily, I'm going to say there are 3 approaches. The rule of 3. I don't know. There's more approaches than 3, but I'm just going to say there's 3. So the first is in situ. So if the code is relatively well formed, if it doesn't exhibit too many pathologies or dysfunctions, if it's not that broken or that big or that ugly, you can refactor it in place. People much smarter than I, Martin Fowler et al., have described how to do this. It's a fairly, I think, generally well understood sort of approach. The second approach is cloning. This is where I've got a bit of code that I want to modify or refactor, but I want to do it in a safe place. And I know that some of the code is reusable and of benefit, but I want to add some things. So decouple it, facades, proxies, wrappers, take a copy of the code, put it in a safe place, tear it apart, build the new thing back up, reintroduce it to the code base. And then the third approach is to build one in the parking lot. This is simply the idea that you go off and you build a new thing. Now, Spolsky calls out very appropriately that one of the most foolish decisions you can make is to rewrite the whole thing. Number one, it's rarely going to be economically viable or beneficial to the business. You need to be more nuanced and more targeted than that. So what I'm talking about here is rewriting a service or rewriting a component or a discrete area of a product, not rewriting the whole code base. As much fun as that might be, the fact is you're probably never going to be given the opportunity to do that. And if you do, as Spolsky points out, that can be one of the worst strategic decisions that you make. Down that road lies madness. Teams. So if I'm thinking about then, I've broken these up into domains, this code base up into domains. I've thought about how I want to approach it. How do I think about the teams that are going to do this work? The first approach is one team, one dream. That is, you have the team that owns the code, refactor the code. There's a couple challenges with that. One more philosophical and kind of not very nice, and then one more real for us, for engineers, for real people on projects. The first thought is, well, if you were going to refactor it to make the code better, why didn't you all do that in the first place? Is the team really capable of doing that? Can they step out of their context and rethink how they're approaching the code? But more from a pragmatic, from a real perspective, what usually happens is you're never going to be provided that opportunity. The team is going to be so consumed with demands for new features and new capabilities that it's going to have a tough time stepping away to do the refactoring work. So then the second approach is a team A and team B. This is not so straightforward either. If I pick a team A to go off and refactor or build the new thing, and I have a team B, that sort of implies that team A are the winners, and team B then are the losers. That's difficult, right? Number one, it's not true. And number two, what winds up happening is team A can be consumed with hubris. We're the special people, we're smarter than everybody else, those fools and their poor little pitiful system, we're going to just ignore them, and they can fail to leverage the expertise and the knowledge of how the system actually behaves and operates. That's one of the dangers of pilots. Pilots are a great way to drive innovation within an organization, but one of the challenges is you can develop hubris again, sort of arrogance. You can assume you can forget this, that often a pilot team is provided a level of freedom that the rest of the team is not. So they're allowed to bypass certain rules and regulations and do things differently. So don't infer too many lessons from that, or be thoughtful about what you infer from the success they have, because now you've got to replicate it across the organization. You also don't want to walk away thinking, well, this team is just smarter. Right? That's nonsense. The last approach, the third approach, because we have three of everything, right? The rule of threes, is the NewCo. So the idea here is fairly straightforward. What you're going to do is you're going to spin up a new company. I've been with organizations where we've literally walled people off. We've branded the team. You run up a pirate flag, right? You give them absolute focus and concentration, and they go off and blaze a new trail. This can work really well with the idea of either cloning or building one in the parking lot, right? Another key aspect of this is what you could do is you could set up, say, 3 teams of 12 each and have each team go off and drive towards the same architectural goal or innovation goal, and then measure the output and see what each team did in terms of their approach. So on to the crux of the conversation. Organization leads the way. So some rules of the road. Technology's easy, people are hard, are wicked hard. Conways and other laws. So I think everybody knows Conways Law, really straightforward. The idea is that the software product that an organization produces will mirror the structure of that organization and the communication channels within the organization. So Conway famously said, if I hand 4 teams the problem of building a compiler, I'll get a 4-pass compiler. Organization shapes the product that the organization produces. But it's more than that. There's some key implications here. What that means is that if the product structure and the team structure don't mirror one another, if they're not isomorphic, what will happen is you'll produce bad software, right? You'll create processes and handoffs and reviews to try to manage that impedance mismatch. You'll be slower, you'll build crappier software, and the teams will be less able to sort of move forward with velocity. The second idea is that you need then to model your cost structure in a way that it maps to those teams. Because if you don't empower teams economically, you're not really empowering them. So as I'll talk about in a second, product structure, organization structure, and financial structure need to all mirror one another. In the end, what I'm talking about is a service-oriented organization. So I'm an engineer, I'm an architect, so I think everything relates to software. And in the 1990s, I was working on a book on nonlinear organizations, like how to structure organizations to move fast. And some of the thinking came from observing like small talk systems versus other systems, this idea of small autonomous objects that you compose sort of dynamically at runtime to perform behaviors versus more static systems. Also, I was in the healthcare space at that time, and we were coming out of the shift from the indemnity model to the managed care model. And what happened is EDI communications that were very common within the healthcare space were based on these very static and difficult to change standards. And that shift in the model broke those standards. So while EDI was very fast and very efficient when nothing changed, it didn't deal with change very well. So it got me to wondering, well, how do you structure an organization so that it's flexible and mobile and can respond to change, it's resilient, but still behaves effectively and efficiently? At that time, Evans and Worcester with the Harvard Business School wrote a book called Blown to Bits. And they talked about deconstructing and reconstructing value chains. This was around the same time that Don Tapscott was writing about disaggregation and reaggregation, right? So you view a value network and you sort of blow it up and you recompose it to create new value. And Evans and Worcester, in their book Blown to Bits, they talked about object-oriented design of organizations. And I'm like, wow, that's awesome. If you think about it, what we do with services in a service-oriented architecture, although that's a bit of a dated term, what you do is you define, whether it's an object system, whether it's a set of services, whatever it might be, you define a well-encapsulated entity with a very specific contract with the rest of the system. It has an interface that you interact with, right? Its implementation is opaque. If I think about that in terms of teams, I might have a team that uses Jira and Scrum, and a team that uses XP and Rally, and candidly, as a leader, I don't care. As long as they fulfill their contract with the rest of the organization, that doesn't matter. And that really hints at where I'm going. I want you to think about teams like you think about services or products, right? Well-defined interface, internal implementation, all the knowledge and capability that that team needs to deliver the goods. That means product ownership, the truth, the business. That means UX, IA, web design, editorial. That means architecture, development, test engineering, and DevOps. A quick aside, DevOps is not a liaison function between IT and development. DevOps is part of Dev, hence DevOps. You want a tight, cohesive team with all the capabilities required to deliver that specific service or product. If you get that, what that allows you to do, just as in a system, is that allows you then to localize change, to have things behave in unison autonomously, and it allows you as a leader of an organization to move quicker, in parallel, individual teams operating autonomously. It also allows you to distribute the teams. One of the worst things that you can do is take the work of a team and break that up into bits and pieces that are done by different people in different places in the globe. What winds up happening, and it's happened when I went and lived in India for a year, part of the reason I did that is I'd just come off a horrendous offshore implementation. This is how bad it was. We wrote specifications and described, like a given page, right? And we put examples of dynamic content in as static content. The code we got back, that static content was directly embedded in the page. When we got the code back and we looked at it and wondered why it wasn't performing, we found that it had that a given category page had 1,500 database invocations and 1.5 million method calls, right? That lack of interacting with the team directly led to bad outcomes. So when I walked into the last place I was at and I asked them, I challenged them and I tried to say something provocative. I said, from my perspective, when you're talking about your development life cycle, the Ideal SDLC produces no artifacts. The only thing that is produced is the software itself. And they busily explained to me, well, no, that doesn't work because we've got to write the BRDs, and then this team over here in Taipei has to code, and this team over here in India, then they need to test specifications so they can test. And I'll challenge you the way that I challenged them. That is a reflection of a broken process because of a broken team construct. The most effective team construct is a small, cohesive, co-located team. We're human beings. You need to talk to one another. Cultural context is important. Language is important. That ability to talk, to understand without having to explain. That's what drives speed and efficiency. Measuring a rate card because a rate is lower here than over here, that's a false efficiency. What will happen is the frictional cost of handing these work products across geographies will consume any of the benefit that you get from a lower rate. So, the whole gang, the best team is a whole team. Slice cheese, not time. Context switching is expensive. Focus and time are your most scarce resources, not money. And we are the world. Distribute work based on whole teams. So I'm really short on time. I'm going to move through this pretty quickly. This simply reiterates the idea that you map your product architecture to your organization architecture, or rather your organization to your product. So you have a team by each service. You distribute decision-making authority and decision rights around funding down into the teams. Ryerson and the principles of product development flow called this distributed economic decision-making, right? It's this idea that you want to empower teams to make the decisions as long as they're in line with the global objectives. Organization will drive behavior. Distribute work, right, or distribute the teams, don't distribute the individual deliverables. Frictional cost will eat any rate benefit. So if I have to pass work from one place to another, the effort required there will consume any benefit I'm getting from a lower rate. What you want are whole teams. Product owners defining roadmaps, teams, sprint teams under the product owner, working a backlog, fixed capacity, work the backlog, deliver the roadmap. Autonomous teams, empowered, autonomous, everything that they need within the team to deliver. That is the way to speed. That is the way to parallel efforts, right? That's the way to scale an organization. And that's the way to approach refactoring code. Lastly, again, I'm going to recommend DeMarcos' book, Slack. There were a series of books in the 80s on software engineering cultures. Lister and DeMarco had one called Peopleware. It was something I discovered in the 80s, and I think I bought 50 copies and left them on every manager's desk that I worked for. It talked about building great cultures for software engineers. This was a time when there were a whole bunch of those little books like Wicked Problems, Righteous Solutions, Programming Pearls, Psychology of Computer Programming, The Mythical Man Month, etc. DeMarco came back with this book, Slack, and it talks about the myth of total efficiency, right? If the team is fully utilized on delivering feature work, they don't have mind space then to think, right? So that 100% utilization is a false efficiency. It makes the team unresilient, unable to respond to change, and it robs them of their time to think. Software engineering is an intellectual activity. Teams need to be able to think if you want to drive creativity and productivity. So in the end, organization leads the way. That's the key thing. A broken organizational construct will diminish to near zero your chances of a successful outcome in a re-architecture effort, a re-platforming effort, or in software engineering in general. Last few thoughts and then I'll close. One of my favorite lines is that the software is not done until the last user is dead. Architecture is an ongoing activity. I always relate it to like a garden, right? And I'm your fertilizer supplier, right? So I'm gonna provide the cow poo. What you need to do is you need to always tend to the garden. You need to weed it. You need to take care of the plants. Otherwise, eventually, it will die. So architecture is not a discrete task. It's an ongoing activity. It's not simply drawing a layered cake. Just stop the darn layered cakes. Real life is more complicated than that. The architecture will evolve over time, and the environment in which it operates will evolve. Be prepared for that. And you'll be surprised. Don't try to eliminate ambiguity. Test early and often. You'll be surprised by what happens in real life. A broken structure will result in broken software, period. The ideal development process, has 0 artifacts. 0. Be biased towards that. Doesn't mean you'll be able to achieve it, but that should be your goal. And value progress over perfection. It's more important to move forward, to test, to try, to iterate, to learn, to evolve, than it is to sit back and try to anticipate what the future holds. Real life will surprise you. So in the end, the takeaways I'd like you to leave with from this talk are these. The key determinants of success are social. Technology is really easy. It's fairly straightforward. The hard problems are people. How do you organize them? How do you approach a problem like refactoring a legacy system? Organization leads the way always. A healthy organizational structure is a key predictor of your success. And in the end, behavior matters. So for you as individuals, and especially for those of you who have the opportunity and the luxury and the benefit of the gift of being able to lead teams, no matter how big, there's some key things to remember. Show courage, right? Speak truth to power, always tell the truth. Don't try to anticipate what your audience wants to hear. Be clear, be pragmatic, be applied, be real. Don't attempt to get rid of all the ambiguity. Just suck it up and deal with it. Increment and evolve, build constantly, launch early, iterate madly, test and experiment. All 3 related ideas, straightforward. Likewise, avoid the moonshot, avoid the big bet. Don't bet the whole company on one idea. That's a fool's errand. And again, leverage business opportunities. Understand that elegance in a solution comes from the constraints of solving real problems. And in the end, the most important thing, when I was a first-time leader of a real team, like real team of architects, not doing support or anything like that, but I mean real architects and engineers, it was on the Advanced Cruise Missile. This was a stealth air-launched cruise missile. And we were doing hardware-in-the-loop simulators, right? Really fun stuff. And I had an amazing team. Kai Trong, one of my engineers, was fabricating custom hardware boards to real-time take, 24-bit big Indian data and convert it on the fly to 16-bit little Indian, right? He was doing interfaces with avionics systems and all this. Gene Payne, one of my other engineers, was doing this awesome telemetry reduction, unpacking, and all this sort of stuff. We were doing really cool work. And my boss, one of my mentors, Joe Valea, and this is how much this landed with me. This is 1989. What he told me when he gave me my first review is he said, "You stink." He said, "You're a bad leader. The problem with you is you're so convinced that you're so smart and you understand everything so well, you're crushing your team. Your job as a leader is to hire great people, to give them opportunity, and candidly, and pardon my language, to get the hell out of their way," right? It winds up being the easiest job in the world because really all you're doing is not screwing up other people's work, right? You're making their success visible. If there's, arrows or bullets coming in, you get in the way of that. But outside of that, hire great people, give them opportunity, get out of their way. This is not some Gandhi-esque drum circle, encounter group kind of thing. If you want to view it as being purely selfish, view it this way. If you do that, those people will be smarter than you as an individual will ever be, and they will make you look brilliant. So if nothing else, do it for that reason. Do it for the most selfish of reasons. But your job as leaders is to serve your team. Listen to their wisdom, listen to their insight, acknowledge the realities that they deal with, right? And even though I'm doing kind of hand-wavy BS, because that's where I am in my career right now, right? That's what you do. You go to the dark side, you stand in front of rooms, and you wave your hands. Even though you're doing that, realize that at one point you are an engineer, you are an architect, value and honor their work, value their intellect and their insight, give them opportunity, turn them loose, empower them, drive decision-making down into the organization, unleash them and focus them on specific areas of the product architecture, and you can achieve speed and success and build great world-class software product. It's literally that simple. Easy stuff. So with that, I am done. Thank you. Jakuya, is that right? Sort of good? Okay. Thank you very much for your time. I appreciate it. Do we have time for questions? Okay. Wow, that's a surprise. I always run long, so that's good. Please, I am happy to answer anything. As my teams with Sabre here in Krakow, the people I have the good honor and privilege to work with will tell you, I will answer anything. So feel free to ask me. If you thought something on there was complete nonsense, challenge me, ask, feel free. Any questions? So it was just brilliant. It was perfect. Awesome. Okay, well, very good. Thank you for your time. Thanks again for your attention. It was very nice of you. Have a great day. Enjoy the conference.